Hello, welcome back. Our lecture or video today is about linear regression in Python. The last couple of videos I explained the linear regression, the theoretical part of the linear regression. Now we would like to see how to use linear regression in Python. So let's start. So as you might know, this pandas library, it used to read files and manipulate files. So let's do it. So as you can click just to run the selected lines. So let's have a look on our data set dot head. Yeah, as you can see here, we have 4 variables. Try to predict the profit. So this is the startup, 50 startup companies. So as you can see here, you could also see how many lines, or here's number of rows, number of features. So this number of features 1, 2, 3, 4, 5, and number of rows is 50 from 1 to 50. But start here in Python from 0. Yeah, let's explain what this data is about. Sorry. So here's assume that you have, I think this are real data. So there was 50 startup companies. For example, the first one spent this amount of money in research and development, and this amount of money in administration, this amount of money in marketing, and it was this company was in New York, and they got a profit about this amount of money as a profit. The next company has this amount of money, spent the amount of money in research and development, and etc. And as you can see here, this is administration, has less money in administration. So in Florida, and they have this amount of money, it's less than this one if they have administration. Let's have a look on which attribute has the much effect on the profit. In another meaning, it means which amount, if you spend, for example, much money in research and development, will you get much profit? Or if you spend much money in administration, will you get much profit? Or we'll see it in the next lecture, in a couple of slides or lines. So stay here and we will do it. So as you can see here, we have numerical data and categorical data. So as you might know, machine learning in Python, it only work with numerical values. So how we have to convert this text in numerical values, we will see. So in the first step, I just remove or just take the numerical values. We will have a look. Dot head. Yeah, you see, just we have 4 variables, and the state it's not there. So the state has to be alone. We would like to convert it to the numeric values. If you have, in your case, if you have much categorical values, you should put it there with just this one and etc. Now, to convert it to convert this state in a format that is usable with linear regression or any algorithm, we use this library. So it's here label encoder and etc. So we have to create one object of the label encoder, and label encoder dot fit and transform state. So because we need to convert state, and try to print these values. Yeah, as you can see here, 201, as you can see here. For example, 2, this is New York. Number 2, it's they do it in So number 2 it's New York, number 0 it's California, 1 it's Florida. But as you see here, 2, 0, 1, this is treated as New York is better than California, or etc. Or for example 0 it's a less value or less weight. So we need somehow, I mean, there is no difference between these values. For example, New York or California or Florida, they have the same weight, or let's say weight. So we have to convert it to one hot encoder. One hot encoder, it's the same. Yeah. Create an object from this class, convert our state, convert the result of encoder into a matrix or array, and use one hot fit and transform. As you can see here, we have the first row is 0, 0, 1, so it means New York. It's only for each row we have only one value, the other values are 0. So as you can see, 1, and here's only 1, and here's only 1. So this one, it means this is the city of New York. This one, it means the California, as you can see here. This one is Florida. Now let's just name all of these values, because it's not clear for me or for you as well. So let's see here how it's working. Yeah, see, it's California 0, 0, Florida, New York. As it's the same, but we need the column names. So if you have an array and you would like to convert it to data frame and use column names, just use this function panda or bd. We define this variable here, dot data frame, and etc. This is the array that you would like to transform, and here are the column names. So now, as you see here, our values are for example here, this value is less than this value, and there's a gap between these values. For example, this one, it has its small value regarding this one, so it will be considered as null. So the best way, or the advice before using machine learning, you have to transform or normalize your values. So in that case, this column will be, the values of this column will be between 0 and 1, and this one between 0 and 1, and this one between 0 and 1, and etc. If we have many converter. For example, here I will use minimax. You could use standard deviation, and etc. So let's do this one, and as you can see here, let's have a look. Oops, the scale. Yeah, see, it's all of these values between 0 and 1. This column between 0 and 1, and also this one, etc. Let's convert it to the data frame. It's better to see it in this data frame. So x dot head, this our final data. It's as you can see, the original data, but normalized, and also this one is transformed. So we can see there is no text. For example, New York or Florida or New York or California. We have values, real values. So let's see we see number of columns. So our columns, it's this one, the first one, administration, marketing, and profit as well. Yeah, so now let's split our data so that the class has to be removed from the X. It will be in one variable. We would like to predict the the profit, so we have to remove it from the training, of course. So as you can see here, now X has only 4 variables. There is no profit here. So if you have a profit here and you would like to predict profit, it will be 100% correctly. So you have to remove it. Now let's use this statistical models. This, I think, from my experience, this is the best library to use. So here, and we have to add one constant variable. This constant variable it used to predict, or it used for the y-intercept. If you don't have what does that mean, I have some videos in the linear regression. You can have a look. So let's add variable and try to fit our data to this model, or also create a model. And here we have the result summary. What you would like to have to see in your, if you apply this model in your dataset, you have to see this value. This value, when it's close to 1, it means your model is good. When it's close to 0, your model is bad. So you have to see, you have to do, for example, normalization. You have to fill the missing values, or you should use a different machine learning algorithm, and etc. So now let's see. This is our const. Const is y-intercept. It's 0.14, and this is spend, research and development. And what we should see is b value. Once the b value is close to 0, it means this variable it's used. It has significant effect on the class label. In our case, it has significant effect in the profit. So let's see. For example, this research and development. Oh, it's 0. It's almost 0. So this means research and development has significant effect on the profit. So if you spend much money in research and development, you will get much profit. And this one, it may b values, if it's greater than 0.5, 0.05, it means your model, your features are good. And administration, in this dataset, administration has less effect, so it hasn't significant effect. So if you administration, spend much or less money in your administration, you will, it's not has much effect on the profit. And let's say, for example, in California and Florida, it has some effect. It depends if it's in California or Florida as well. Yeah, I think we have this. Now we would like to predict our data. So in this case, I will try to predict on the training model as well. So in the real life or real applications, you have to split your data into training and testing. We will see this in advanced topics. So let's see, we have our model, this one. Dot predict, we would like to predict the X, the profit in X dataset. So let's see, let's have a look. So this is the predicted value, as you can see here. And to compute the error with our predicted values, we have to use this matrix. And here's the class. What we have in the class is the profit value. So before, see, this is our class we would like to predict, and this is what we already predict. So we compute the mean square error. So in regression, the best way is to use mean square error. We will see here it's 0.002. It's less value or value close to 0. It means your model is good. So what you already predicted, it's close to the real data. Yeah, I will put this code in the description so you can have a look. Yeah, if you have any question, just drop in a comment. I will reply, of course. Thanks, and see you again.